Hi, AB students. How are you? I am working on grading the exams. I have not looked at them yet, but I'm sure you did splendidly. I hope to have them done at the very latest by Saturday. I apologize for the delay. It took me a while to put together new reviews for the AP test based on the situation. So let's start with an informative video. So first, you should definitely be checking the College Board website and looking for updates, but let me point out a few things for you, okay? So first thing, let's watch a little intro video. Make you watch it.
This year, you can take your AP exams online. Here are a few things you can do to prepare and practice for them. First, click on the AP exam schedule on our website and scroll down to course-specific exam information to learn details about your exam, including what material will be covered and what materials you'll need to take it. Then, check in with your AP teacher for additional guidance about what to practice and what skills you should focus on.
That's me.
Review key concepts with video lessons on the AP YouTube channel. Go to AP Classroom for free response sample questions.
I'll include a link for the video
And
lessons.
visit the exam demo on our website to see what the online exam experience will be like. Finally, set a reminder for the date and time of your exam, making sure it's correct for your time zone. And on test day, don't forget you'll need to log in 30 minutes before your exam and have your AP ID handy. For more information, go to cbe.org/AP2020.
All right. So, stop. All right. As far as other stuff on the AP exam that I'd like you to see, or the College Board website, under students and coronavirus stuff, if you look at the AP exam schedule and say view the schedule, that's where you get course specific types of things. Your exam is Tuesday, May 12th at noon, though you should log in a half hour early, as they just said. So 11:30, prepare yourself for 11:30, May 12th to kill it. All right, so if you look down at the math part of this, so sorry, and get to AP Calculus AB, a couple things I want to hit before I start the review. So you can see the exam, it's two questions. One is 25 minutes, and then you have 5 minutes to upload it. One is 15 minutes, and then you have 5 minutes to upload it. It's important to note that they don't let you go on to the second question, so I imagine so not everybody's all at different places in the exam, and you can't text your friend, I don't know what. But you might as well take your time and, excuse me, on the exam demo I saw, they had a timer at the bottom showing you how much time you have. Make sure you leave enough time to upload. And the exam demo walks you through practice. You can practice uploading either a photo or PDF, JPEG, or copy your text in. So sorry. Um, but anyway, it'll be two questions. One will be longer, 25 minutes. Another will be 15 minutes. Both of them you can expect to be multi-focus. There's going to be a lot of different parts to each one. So a question might have derivatives and integrals and limits in it, or it might have motion in it or applications in addition to U sub technique. You can expect that to happen now. It's also important to know, that Unit 8 is not going to be on the test. We might talk about that a little bit, but that won't be a focus. We'll talk about that next week. Also, I thought this was interesting. You can expect the problems to be no calculator, or you don't need a graphing calculator. Not everybody has a graphing calculator. Students who are less fortunate and don't even have their own and borrow the schools, whatever. They can't assume that everybody has functions of a graphing calculator, so all you will need is a 4-function calculator for the exam. You can imagine then that that'll change the nature of the questions. All those questions where you find intersections and all that stuff on a graphing calculator are not going to be there. They'll have to be dealing with pretty clean functions, I imagine. Um, and remember that for numerical answers, you don't have to simplify, so you could leave an answer as 3 times 5 over 2. I think that's atrocious personally, but whatever. Um, and that's acceptable. You may not leave trig unsimplified, so you couldn't leave an answer with sine pi over 6 in it. You're expected to simplify trig answers. You should consider going to the references and guides to download documents you'll need before the exam day. I haven't actually looked at that. But that, if you're going to use keyboards, if you're going to keyboard your responses instead of writing your responses, then you should definitely look at that, okay? We'll talk about, there's a keyboarding tip sheet for 2020 AP Calculus exams. We'll talk about formulas and organizing your notes. It is open note, but you don't want to be spending too much time looking at your notes, all right? So you want to know your stuff. Excuse me. All right. So then, where are we at? Well, we're learning here. All right. So I wanted to give you a little AP exam format info, and I encourage you to go there as time goes on and take the exam demo, just practice uploading questions. But let's more importantly do some calculus. That's why I'm here. All right. So unit 1 is limits and continuity, people. This are on a typical year. Normally, limits and continuity would be about 10% of the exam. Now all bets are off, so how much of the exam, I'm not sure. By the way, when it said Unit 8 is not on the exam because they threw out anything you might have learned in March or later than March, that means applications of integration are out. So we'll talk more about that later, but that it breaks my heart, quite frankly. But it is what it is. You got to deal with the cards you're dealt, so here we go. In an outline, this isn't really your typical outline form, but these are the big ideas of limits they consider in the skills, all right? So the first is the idea of limits are necessary for talking about change at an instant. You can't take change between one point, you have to take change between two, and then what happens. So basically limits are required for derivatives, and then the number of rectangles going to infinity. Limits are required for integrals. So limits are the foundation of all calculus, all right? They are going to focus on limit notation, so you need to be able to make sure that you write proper limit notation when you've evaluated the limit. You don't write the limit anymore. You should be able to find limits from graphs. That usually goes pretty well. Limits from tables, that was bad on a multiple choice. I'm going to talk about in a minute. Algebraic properties of limits, that's like rationalizing or canceling so that you can get rid of a 0 over 0. We've talked about how 0 over 0 is do more. Do more then would involve some algebra in this case, all right? So that's possible. That's the same as algebraic properties of limits, is you can break limits into separate limits if there's a sum or a product. Sorry, my bad. Algebraic manipulation, that's what we were just talking about. Selecting procedures for determining limits. The first thing you should try is direct substitution. If that doesn't work, then you have other options. We'll talk about L'Hopital and stuff later. But direct sub is your first option. The squeeze theorem, gosh, if they put that on, that's a pretty small idea of calculus, but I guess we could practice it if we need to. We'll see. Multiple representations of limits, that could be a table, an equation, a graph. When they say multiple representations. Exploring types of discontinuities, we're talking removable. Maybe I should start writing. 0 over 0 is a hole. That's a removable. Sometimes you can fill in the hole to make it continuous. There's a vertical asymptote or asymptotic discontinuities when you have non-zero over 0. And then there's jump. Jump is when you have, by definition, jump is when the left-hand and right-hand limits are not equal. Okay? defining continuity at a point, this will be maybe something we put on a reference sheet. Continuity by definition is the function is continuous if the limit exists, which means the left and right hand limits are the same, the point exists, and the point and the limits are the same. Confirming continuity would use that definition. You would have to prove continuity. Removing discontinuities, that's a more common multiple choice, but I suppose who knows what this exam will look like. Possibly you could fill the hole. You can't remove a jump discontinuity. That's when they say removing discontinuities, that really means filling the hole usually. Limits and vertical asymptotes, you need to know that if you get an infinite limit, that implies a vertical asymptote. And if you get, as x goes to infinity, you get a constant, that implies a horizontal asymptote. All right, so in both cases, it's one of the variables, either x or y, going to infinity, while the other variable goes to a constant. And working with the intermediate value theorem, remember the requirement is continuity. Okay? And between this, obviously. All right, moving on then. So these are some of the most missed questions on the multiple choice unit 1 that you took not too long ago. All right, so excuse me. You can see here, here's the numbers. On this question, which you took about, 3-4 weeks ago, 43 people showed up to take this, and 30 of you missed it. So let's talk about, you can see the different answer choices and which one the correct one was, but let's go over this, all right? So you've got a function here, it's x to the 4th, which could look a lot of different ways. I can't remember if this was calculator active. It was calculator active. So question is, for how many positive values of b as x approaches b, does the y approach 2? You should think then that how many different b's are there, or how many different x's on the graph where y approaches 2? So you should graph this in your calculator, which I guess this would not be on the test, but still this concept that I'm focusing on. And you would say, depending on what the graph looked like, you'd say, all right, how many places does y approach 2 at? And I assume the answer was 3. I'm not sure why people said 2, but it equals number of people said 2. So I think I've opened those exams back up so you can go back and look at what you said, but that's the idea. You'd find out how many places the graph approaches 2. Question 4 was missed by about 40% of you or so. So let's read it. The position of a particle moving right is x, okay. X is measured in inches, t is measured in minutes. If y equals x of t is a linear function, so now y is the position horizontally, so maybe y equals whatever, 3t plus 5 or something like that. It's a linear function, and the outcome of this gives horizontal position, which is the best estimate of the speed of the particle in inches per minute at time 20. All right, so I would open my mental file here and say speed is the absolute value of velocity. Velocity is the derivative of position, which for linear is the absolute value of the slope of the position function. And if it's moving to the right, isn't the position going to have to be increasing. So this has to be positive. So I don't even know if this absolute value needs to be there. It's just the slope of the line. So how do we find the slope of the line? Well, I assume that when people chose that bogus solution, that instead of finding the change in position over time, they just said, ah, screw it, I assume it started at the origin, which it doesn't say that ever. And so that's why you said that answer, which is bogus, when in fact it is that guy right there, the slope of the graph. All right? All right. This was a disaster. Look at that. 35, only 8 people, 1/5 of the people got this question right. This must be hard. Let's see. The table above gives the values of the function at selected values of x. Which of the following statements must be true? So it looks like as x approaches 1 from above and below, these y values are getting close to 7. These y values are getting close to 7. So it seems like I'm thinking the limit as x approaches 1 is 7. And that is what you guys chose. Now, why was that wrong? Ah, they got us, didn't they? All right. I guess the key word there is must be true. And so they left off with a window between 6.9 and 7.5. So that, and here. Now, that little gap of x results in a little gap of y. So just because the y values are showing between 6.95 and 7.05, does that mean the limit has to be in between? Well, no. Could it be 7.01? Could it be 7.02 or 6.9? So too much gap, and that word is the gotcha in there. And I assume that you did just what I did. You said, oh, I know calculus. Here I go. Choose my answer before I read all the other possibilities. And you didn't maybe slow your roll and think, oh, wait a second. A table doesn't show everything. All right? All righty then. This guy is, we're a little bit rusty on that bad boy. This one, if you were to simplify this, first of all, would you need to simplify this, or could you direct substitute? And I think you'll agree it's 0 over 0, so you need to do more. Could you take L'Hopital? If you get 0 over 0, isn't that a L'Hopital case? And the answer is yeah, it would work. Now, unfortunately, it wouldn't exactly give you the answer choices, but it would give you the answer, and you can see if the answers are the same as these. But the actual limit, what they're asking you to do is really multiply by the conjugate so that you get something like, what? X minus 9 over x minus 9 times root x plus 3. Now, I'm going to, for the sake of free response, I want to talk about something here, all right? They will care about notation. They're looking at your work now. And so the idea that you would drop the limit here, that would cost you. You are still, you haven't evaluated the limit when you did that. You still need to say, hey, x is still approaching 9, I haven't done the limit yet, so that needs to be there. That's a sure sign of somebody that's calculus is shaky, okay? Evaluate the limit. When you actually get an answer and say, whatever, 12, that's when the limit's no longer there. But until then, the limit's there, all right? Oops, my bad. All right. This one more than half of you missed. So I can only assume that you, I'm not sure what happened there, but You could do more. You could do L'Hopital. Again, you could preferably just simplify it algebraically. Do you agree you can divide out an x? 7x to the fourth plus 5x plus 12 over 3x to the fourth plus 4. Then if you direct substitute, you get 3. Why in the world did you miss that? Shame on you. Oh my gosh, I see why. You looked here. And what are you assuming then? You're going too fast. You're assuming end behavior. That idea of, oh, I just look at the biggest power. That's as x gets infinitely large, not 0. So read the limit, all right? Question 18 was also an unmitigated disaster. This is a sure sign that you don't remember your identity. So let's go here. I think you'll agree again that this is 0 over 0. And so you've got a choice to make. You could use L'Hopital if the answer was what's the answer, if the question was what's the answer, but they didn't say find the limit. They said which is equivalent. So what they're asking you really to prove that you know how to simplify. Use an identity, and if you know algebra and you memorize this one identity, then you are in really good shape. So as far as sine of x minus 1 or cosine squared is 1 minus sine squared. And if you factor, that's 1 plus sine of x, 1 minus sine of x. Those are not the same. Order matters in subtraction, remember? Do you remember that? Okay, so if you want to make them the same or to allow you to cancel out, you would have to factor out a negative, so the order would change, and then you could dump, and that's where they're getting their answer. Now I'm starting to get frustrated, darn it. All right, so here we go. Here's the free response. And let's pause for a second. I want to see how long this video is taking. All right, I'm at 22 minutes. Yeah, I got to finish this and Unit 2 in 8 minutes. I'm trying to give you a half hour to work on the free response for your homework, so I'm not going over the hour limit for the day. So why am I still talking? Get going. Let's go. All right, so here's the free response you did. It's basically, can you interpret a graph here? The first one, here's F, and here's the table for G. So the first one is, now the reason they say estimate, you might say, what about that same table problem? Well, I think in terms of a free response, they would take anything value between 1.999 and 2.0001. So if you said 2.00004, it would work, okay? But I think the logical thing would be to say that x approaches, or f approaches 2, and y or g approaches 2. Sorry. So this is 0. Now, this is the kind of question you can expect on the AP exam. They're hitting a lot of things here. They're hitting, can you hit a graph? Can you hit a table? Remember the rule of 4s. You show calculus on a graphical, numerical, which is table, verbal, and analytical. So they're trying to cover, you can imagine their shoes. They want to get as much calculus covered in their questions as they can. So you can expect a multi-dimensional question, right? B, for each of the values a equals 1, a equals 2, 4, 6, blah, 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 find the limit as x approaches a on the graph, f is the graph, or say why it doesn't exist, use correct limit notation in your answer. So, for example, the limit as x approaches 1 of f of x, that's correct limit notation. The 1 would be a case of D and E. Now let's talk notation. D and E is acceptable, by the way, but you can write does not exist. They don't want you to say because the left hand blah blah, just use notation, because the limit as x approaches 1 from the left equals 1, and that's not equal to the limit as x approaches 1 from the right, which equals 0. That's what they're talking about when they're talking notation. Do you know how to write calculus? That's important, okay? That keeps me from having to write a paragraph. So that's what they're talking about when they refer to correct limit notation. If you look at 6, 4 is pretty straightforward. The limit's there. 2, I bet, would get people. I imagine some people will say, no, the limit doesn't exist at 2, which is stupid. Yes, the limit exists at 2 because we're not talking continuity. We're talking limits, and the left hand, right hand are the same. 4 is an easy one. It's a layup. The limit exists, and it's -1. At 6, the dot means nothing. Again, I don't care. It's not about continuity. They would probably take 2 answers. Either the limit does not exist or the limit is infinity. I would probably say both. I would say something like the limit as x equals 6 does not exist because the limit as x approaches 6 is infinity. The true definition of limit is what numerical value do the y values approach as x approaches the given value, and infinity is not a numerical value. But that is a cover your butt kind of answer. I said enough, but not too much. Oops, wrong way. Come on, Corey, we're running out of time. Is f continuous at -3? And the answer is no. You would say in this that it's not continuous because you would say complete sentences because the limit as x approaches -3, which is -1, is not equal to f at -3, which is equal to 2. You could say those in separate statements as well. All right. Difference quotient. This is a disaster. What difference quotient? Difference means subtraction. This is verbal calculus. Quotient means division, or in this case, difference quotient is code for slope between 2 points, which we then use in derivatives a lot. Difference quotient is code for a slope between 2 points. You've got to nail that. That approximates the instantaneous rate of change at x equals 0. So if we're going to try and find the instantaneous rate of change at x equals 0, the limit idea of the derivative is you get as close as you can to 0. So you would use g at 0.001 and g at -0.001 over 0.001. That's change in y over change in x, people. -0.001. And then you plug in the values up here. Communicate your calculus before you go to a table. That's just good math. You don't go straight to the table values. Don't make the person read and say, hey, you got to look at the table to know where I'm coming from. No, you tell them where you're coming from, all right? And then be careful, it approximates. So if you called this g prime at 0, I don't think you would, they never said, hey, call the derivatives. But if you did, it is an approximation, all right? Slope between 2 points. All right, that was the free response and the first one. And, jeez, I'm at 28 minutes. The second one, let f be the function defined by, so they give you this wacky, who knows what the heck kind of rational function, so much missing. The graph has a horizontal asymptote at y equal 3, okay? And f has a removable discontinuity, which is to say a hole, at x equal 2. All right, show that a equals 6 and b equals -13. Let's go with the horizontal asymptote. If there's a horizontal asymptote at y equal 3, remember that's the idea that as x approaches infinity, the limit or the y values should approach 3. Most of you nailed this. This implies that, gosh, I wonder if they want you to, oh, that's so terrible. Truthfully, the technique for finding indeterminate forms, I would just say is approximately a over 2, which equals 3, so a equals 6. All right, and I would go with that. Not a professor would have not found that satisfactory, but that, I guarantee that's enough on the APs. All right, F has removable discontinuity at x equal 2. That means there's a hole, so a common factor. So if f of x is now 6x squared plus bx plus 2, 2x squared minus 8, that implies that one of the factors, gosh, what's the best way to go about this? If there's a hole, that implies that when x equals 2, the top, 6x squared plus bx plus 2 must equal 0, yeah? Hole implies that x minus 2 is a factor. X minus 2 is a factor, implies x equals 2 is a 0. So if I plug in x of 2 into this bad boy, then that will show you, oops, that b has to be 13, I hope. I think that is the case. It better be, otherwise we're in trouble. All right. B, this is filling the hole. This is removable discontinuity work. Gosh, 31 minutes. Okay. So, I need to shorten this up. I apologize. I'm already at 32 minutes and I haven't even got to Unit 2 yet. Let me pause here and think. Okay. All right, so here's the deal. Sorry about that. I took more screen off. I am going to keep going, and then I'm going to go back and watch the video and tell you which parts you absolutely have to have and the other parts that are just for your own edification if you want to go over your mistakes and really fill in the knowledge. All right, so continuing on with this free response that you took a couple weeks ago from Unit 1. It was the second free response. The question is, how do you make this continuous? Now, we know that f of x is now 6x squared plus 13x plus 2 over 2x squared minus 8, which is, what if we factor that out, something like 6x, this is how I would do it, and 2, and you get 12, and you'd have to have a plus 1 and a plus 1. Oops, plus positive and positive, yeah? And that's not true. I think B was negative 13, wasn't it? Yeah. Sorry. So this is negative 13, so these should be both negative. All right. 2x plus 2x minus 2. And with that staring you in the face, it's pretty easy how to see how to fill the hole, all right? We have a hole at 2 because there's a common factor, and we want to fill the hole, but we also want to say it well, all right? To make f continuous at x equal 2, we would say, for continuity, we know that the limit as x approaches 2 needs to equal f at 2. Well, the limit as x approaches 2 of this function, 6x minus 1 times x minus 2 over 2 times x plus 2 times x minus 2 needs to equal f of 2. Well, if I evaluate the limit, or what do I get when I remove the hole, then the top approaches 12 minus 1, or 11. The denominator approaches, what do we got there, 4 times 2, so 8. We would have to let f of 2 equal 11/8 so we could fill the hole. We would put a dot at 2/11/8, and it would fill the hole, all right? And last but not least, at what value of x does f have a discontinuity due to vertical asymptote? It is to be determined, but we know that 6x minus 1, x minus 2, x minus 2, 2, and x plus 2. All right, now that's, remember, that is the case where you have 0 in the denominator and non-zero in the numerator. And so it's not the whole case, it's where else do we have a hole. And so it's obviously at -2. So you would say at x equal -2, there's a vertical asymptote, because the limit there, let's go from the left and the right, is infinity or negative infinity. And gosh, do I have to do a sign test? Oh man, to do it well, I guess I would. Oh darn it, that sucks. So for a negative, for example, as x approaches -2 from the left, so maybe -3, I'd get a negative and a negative, so that's positive infinity, and a limit as x approaches -2 from the right. Actually, once you've shown that you have infinite on one side, I think that would be enough, but I would probably go ahead and show that this at -1 is negative positive, so that's at negative infinity. Therefore, there's a vertical asymptote. All right. So, for Unit 1 practice tonight, your assignment is to go to AP Classroom, and I unlocked AP Unit 1 free response question B, which is only one question, not two. And it should be open. Would you please, let's do this in a practice for the AP style. So what I want you to do is, on the AP test, you're going to write your AP code. I think it's 8 digits. I can't remember, at the top of every page. And then you put your initials. And then you do your work, and it's one question per page. So even if Unit 2 free response that I'm about to give you can be fit on this page, please don't put it on this page. Do one paper. Also, I think it's better to scan clean white paper. Line paper shows up, and they'll take it according to what they're saying, but I think it shows up better white paper. Also, please, some of you, look at your scans. For one thing, your handwriting is atrocious, and these are strangers reading your work. They can't read your work. And second, some of you are scanning these terribly dark, like you're scanning it in your closet or something, all right? Look at your scans, please, so you know whether what you're doing is acceptable. If you're using the CAM scanner, there's a black and white filter. There's ways to make it lighter. Just look at your scan, all right? And make sure the whole thing is in the picture. Some of you are cropping out part of your answer. Obviously, they can't grade what they can't see. So please, please, I beg you, look at your scans. On to Unit 2 I go. Pause for a second while I reset. Okay, moving on to Unit 2. Let's see how this goes. All right, so we're going to outline the big ideas of Unit 2, which is derivative intro, frequently missed multiple choice, and I'll look at the very most and look at the free response, part A that you took, and then your free response, your homework will be free response part B in AP Classroom. All right, so here we go. Unit 2 is here, and it is not here. Hang on just a second. Okay, sorry. Here we go. So the big ideas of derivatives, you can see that the typically on a typical year, the exam weights derivatives and basic derivative rules about 10%, so a tenth of the exam. This is a big idea. Do you understand that the slope between 2 points approaching change at a point? I guarantee you the AP exam will have, I guess I can't guarantee anything, but approximating a derivative with an average rate of change is a big idea, all right? Definition of the derivative, I would expect that to somehow show up, some kind of difference quotient. Remember, change between 2 points approximates change at a point. And if you throw a limit on that, the points get closer together and you start to approach the idea of a derivative. That's the idea of estimating derivatives of a function at a point. Make sure you show approximation in your work. They will look at your work, obviously. Differentiability and continuity, determining when derivatives do and do not exist. Remember, there are 3 cases where the derivative doesn't exist. There's a sharp turn. There's a discontinuity. Remember, if the function's continuous, it might be differentiable, but if it's differentiable, then it must be continuous, all right? Sharp turn, discontinuity, and vertical tangent. If the tangent slope is vertical, then it's undefined. Power rules, gosh, you should be able to do the power rule. Most of you know how to use all these rules. Product rule, some of you still are forgetting to use the product rule. Gosh, if they say, hey, take a derivative on this, man, that's a layup. And if you think for 1 second that you can just, hey, take the derivative of each, that's garbage, and you should be ashamed of yourself. You know the product rule is first stays the same derivative of the second, plus second stays the same derivative of the first. Quotient rule, low d high minus high d low over the square of what's below minus high d low, minus, all right? And the derivatives of tangent, cotangent, secant, cosecant. You should know all those derivatives memorized. You don't want to have to do the quotient rule or something like that to find those derivatives. All right. These are some commonly missed questions on the free response you took a little bit ago, or multiple choice. Sorry, you guys, we missed 30 out of 43 of us missed this question. Here's a trig function, whatever it might be. Which of these, at which of the following points could the graph of f, on the graph of f, could the instantaneous rate of change equal the average rate of change on the interval? Average rate of change is slope between 2 points. Okay, at what point is the instantaneous rate of change? Could it be the same? Well, for Pete's sake, draw it on your paper. That, not so much. Maybe too steep. Definitely not that. It looks like B is the only one that has a possibility of being parallel or same slope. I'm not sure why so many people chose C. That slope is way too steep. So bad call. All right, this question, roughly half, a little less than half missed this. Which of the following, if true, could be used to conclude that f of 2 exists? Just because the limit exists doesn't mean that f of 2 exists, so that's not true. If f is continuous at 2, that definitely implies that f of 2 has to be there, and f is differentiable at 2. Differentiability implies continuity, so if this is true, then that must also be true. So I feel like 2 and 3. And some people chose continuity only. That's ridiculous. If it's differentiable, it has to be continuous. Some of you said 1, 2, and 3, and just because the limit doesn't exist doesn't mean the point exists. All right. All right. For this piecewise function, which must be true, they talk about continuity and differentiability. So as far as continuity, I would say is the limit from the left the same as the limit from the right. Well, as you approach 2 from the left, you get 7. The limit as x approaches 2 from the right uses this function, which is 7. So f is continuous, or sorry, the limit exists. And it equals 7. F at 2, is it defined somewhere? And yes, it is defined and equals the same as we got for that value, exists, and that equals 7. And because they're equal, then yes, it's continuous, so that's a yes. But what about differentiability? Well, think about it. You're talking a slope of 3 meeting a slope of 5. That's going to be a sharp turn, not in between. So no, it's not differentiable. it is continuous but not differentiable. Um, and those of you that said continuous and differentiable, you made a bad call. That's not true. All right. Free response. So you have, again, this is a multi-dimensional problem. This is great practice. I guarantee you they're going to hit a lot of methods. So they're giving you a graph of f and an equation of g and an equation of h, all right? K is defined as a product between f and g, so you'd use the product rule. So hopefully you use good notation and say something like, to be safe, I would say k prime at x is first stays the same, derivative of the second plus second stays the same, derivative of the first, and then maybe go to the specific and use f at 0, use the graph, and the slope of the graph for f and f prime. And for g prime, you could either go off to the side and calculate it, or you could do it in here. Just be organized in your work, all right? B, quotient rule. The function m is defined by that. Find m prime at 5. Again, don't confuse m prime at x with m prime at 5. If you do this in one step and you say m prime at 5 is this, you should always show the general derivative first and say I'm about to put in 5. Do not take the derivative and start putting in 5 at once. You will not get full credit. That's bad calculus. Don't do that. Instead, show the general derivative and say, then I'll put in 5. All right? Quotient rule, though, is low, and that includes, you could put a half out front, I suppose, and call it a coefficient. I just lumped it in with the whole low. Low is 2g, d high is f prime, minus high is f of x, d low is 2g prime over the square of what's below, and that's the square of all of it. And then you substitute in your values. All right. What about a value? If I remember, this is a part that we missed a lot. Where's there a place where f prime in between -1 and 2 equals h prime? Well, let's start with f prime is the slope of the f graph. I'll come back to that, I suppose. H prime is the derivative of h, which is 5e to the x minus 9 cosine of x. Now, I guess I would need to say the slope is twofold for f. F prime before 2 is the slope of that graph. So what are we talking? Up 1, 2, 3, 4 over 2, or 2. So the slope is 2 for x is between -1 to 3. And the slope is -2/3 for 3 to 8. And so as far as using my calculator in here, remember this probably wouldn't be on this test because they are giving you problems that you wouldn't be able to use a graphing calculator for. So you would pick up your calculator here and graph this in H1. I would probably graph both of these separately in F2 and F3, but only think of them in limited regions and then find where they're equal. Okay? And that is it. So your homework for Part B, AP Unit B, is I unlocked AP Unit 2's free response question B, and that should be good. Again, write it on a separate piece of paper, AP code, initials, and then label your work. Why don't we call it Unit 2 free response question, and send that, do it on another piece of paper, but do that and Unit 1's free response and send them in as scans. That's your homework due tomorrow. All right? Well, my video hit 49 minutes. Sorry, part of that was introducing the AP test, and I'm trying to keep it to an hour. I apologize, but it is what it is. Okay? So thank you and have a good day.